Consider a head-on collision. That is, one in which the velocities of the bodies before and after the collision are along the same straight line. The mass of the first body is m1 and is moving towards right with velocity u1. The mass of the second body is m2 and is also moving towards the right with velocity u2, such that the two bodies are moving along the same straight line. If u1 is greater than u2, then there will be a collision between the two bodies. Let the collision between the two bodies be elastic, which implies that it is a completely elastic collision. Let the velocity of m1 be v1 and that of m2 be v2, just after the elastic collision. Since the momentum is conserved, we have m1u1 plus m2u2 is equal to m1v1 plus m2v2. On rearranging the terms and simplifying, we get m1 into u1 minus v1 is equal to m2 into v2 minus u2. Let this be equation 1. Since the total kinetic energy is also conserved in an elastic collision, we have half m1u1 square plus half m2u2 square is equal to half m1v1 square plus half m2v2 square, or m1u1 square plus m2u2 square is equal to m1v1 square plus m2v2 square. On rearranging the terms and simplifying, we get m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. On further simplifying, we get m1 into u1 minus v1 into u1 plus v1 equal to m2 into v2 minus u2 into u2 plus v2. Let this be equation 2. Now, dividing equation 2 by equation 1 and simplifying. We get u1 plus v